Great. Thank you. It's a pleasure to be here. And to be honest, it's the first time in my life I see so many cybersecurity people awake in the same place at 9 a.m. So before that changes, I'd like to start with the TLDR of what I hope you will take out from this talk, is that A, with generative machine learning, cybersecurity changes, but kind of stays the same, and I'll get into why. If you're in a position where you want to leverage it, put a machine learning person into your red team and a blue team person into your machine learning team. Now, hopefully going to stay for the rest of it, but if not, you've got the most important. About me, who am I? First of all, I'm a machine learning researcher. I come from a machine learning background. I'm still active in that community. I've unfortunately been forced to do some cybersec since 2017. Cookie to those of you who remember what happened back then. And I've been specializing in the countermeasures to offensive generative machine learning since 2020 when I joined the Cyber Defense Campus as the second postdoctoral fellow. Cyber Defense Campus that was just on the slides as one of the partners of Trust Valley and other companies here in Vaud and in Switzerland more generally. I'm also co-founder of Gen Learning Center at HSSO, where one of the axes where we're working on is bringing together cybersecurity and machine learning with knowledge from both domains. However, before I start talking about cybersecurity and machine learning, let's define the terms. What do we mean by cybersecurity? Yes, a lot of you have hoodies. If you don't, you probably got some at the booth downstairs where you can get some pretty amazing one, but that's not what defines you as a vulnerability researcher. And to be honest, I would like to go a little bit more widely than just vulnerability and talk in general about hacking. What is hacking? To cite Marcus Hutchinson, aka the guy who saved the world in 2017, there's a reality gap, and hacking is exploiting a reality gap. What is the reality gap between how things actually work and how things people think work? If you see a difference in a way a configuration works in a framework that make people think it's secure because it's not going to pass vulnerable commands, and the way that it really works, which means you can actually split your command across multiple lines and it's not going to see it, you've got a very nice exploit, and you've got a very nice talk here in InsomniHacks, and it's pretty impressive to listen. And to be honest, for people outside hacking community, or just adjacent to it, it looks very impressive because you have this absolute mountain of code, documentation, and you just scared look at it. And then you have somebody who's just looking at it and saying, oh, I'm sure I can climb it in 50 seconds because I see cracks. And to illustrate it, I'd like to start with a small pre-CTF for those of you who are attending the one later today. What this is, it's a RAG application that has been developed by our friends at Effixies, which is based in the Trust, once again, the Tech Trust Center, which is a common application that companies deploy to allow people to chat with their databases. I'm going to go back a little bit more to explain but you have three levels. The way that you would implement it is the first iteration. The second level is how it's generally supposed to be secure, according to machine learning community. And the third is the best recommendations from machine learning community that you find on forums. The preview is that when I sent it to a red teamer at Orange Cyber Defense to see if it wasn't too hard for non-experts to hack, he responded 30 seconds later to me I actually cleared all the levels. Was it supposed to be that easy? So I assume it's not going to last for very long. But let's come back to this reality gap and actually discuss about this reality gap, not from the cybersecurity perspective, but from machine learning perspective. What is Gen AI? You have two fields. You have people who think that it's pretty much a fad, a really good way of collecting money by remaking all of your slide decks from blockchain and crypto to AI. And then you have people who think that it absolutely will destroy the world and we need to nuclearly bomb all the data centers before it's too late. Not sure about you, I prefer the former to the later. However, you probably noticed that experts will generally talk about generative machine learning rather than generative AI. And that's not a coincidence. Words have meanings. And specifically, Gen ML today, what it means is that we took a lot of representations of reality, the way people think about it, have experienced it. For instance, with pictures, the pictures they took, paintings they painted, drawings that they drew, or with text, descriptions of reality events they did. And we train a model that combines it all together and kind of blends it to have a consensus representation of reality and then extrapolates it. So if we are in this area somewhere between Egypt and Persia, it's probably going to be desert. If we are northern, it's probably going to be ice and boreal forests. And to be honest, it works amazing for things that pretty much everybody has a shared experience of. For instance, Matterhorn. No matter which generative image model you're using, you type Matterhorn, you get something that resembles this, very nice. Where things start to break down is when you try to vary a little bit and try to see Jungfrau or Eiger, and instead get this picture that combines Interlaken Lake, mountain cliffs nearby, and unfortunately still Matterhorn. Because once again, the experience that's shared by most people across the world of the Swiss mountain is just a single one. Because we obviously don't have any other. However, despite all of it, generative machine learning is useful and is useful in topics that are immediately relevant to cybersecurity. For those of you who've been in the programming cybersecurity field for more than a couple of years, you definitely remember Stack Overflow. You definitely remember trying to ask your first question and having the responses of type of like, actually, you shouldn't be doing it, or please switch to this new framework, when actually, I'm deleting your question because it's a duplicate of a question that's related to experts, but you see absolutely no way how it's related because you're not an expert. And if you do this today with generative AI, here it's an open model, but you'll get pretty much the same with every other ones, you're going to have a very nice, helpful response guiding you step by step. But unfortunately, you can already see a shortcoming. The model assumes you're a human that's trying to deal with rodents, whereas maybe you're a small cat trying to figure out how to feed yourself by yourself. And this brings us to the fact that generative machine learning is useful but limited. And a really good way to represent it is this tile for longevity that you find quite a lot of in Chinese buildings near the roofs. It has elements that are connected that you can navigate through, but some places that are isolated. So for instance, if you start here and walk on the protruding side, you can walk all the way down here and say, hey, this is amazing. It covers everything. The entire place of tile is covered. However, if you look to the places where you can actually get from this point, you're not going to be able to go there. And unless you find a connection into this area, it's effectively unattainable, which is one of the reasons why large language models weren't useful until they got really large, especially for computing. Because if you are trying to debug something non-trivial, unless the model has ingested somebody's blog post from 5, 10, 20, 30 years ago, it's not going to be able to generate anything useful for you. More importantly, even if it's able to generate it, it's not going to be able to get to it directly. It's going to go all the way around the way that the text has been built, which brings us to the two foundational limitations. Training data is everything, and you can't out-prompt training data no matter what you do. And the LLMs need to be large to be interesting, or at least have large training data sets. So now that we have put down the basics, let's get down to the topic of today's conversation, which is getting into things through classical cybersecurity means and how it changed with machine learning. First, phishing. This gap is so big that you probably heard about it and would be able to exploit it yourself, even if you're not a cybersecurity person or red teamer. This is an invitation to apply for a position that I have received a couple of days ago. I come from a biology background, so it's not entirely counterintuitive that chemoinformatics software proposal would come to my address, although there is something quite peculiar about the signature that would made you wonder, or made me wonder, whether I should be opening this or not, or whether it was malicious or it was benign. Who of you are seeing it and who would not be opening it? Please raise your hands. Who would open it? Okay, good. Yeah, generally people who are in human resources don't sign as resources. However, this email has been written by a person who can make errors. If I ask the system or a large language model that's freely accessible to generate something that would be really attractive to me, A, there's no errors, and B, it's actually really personal and relevant to what I'm doing today. And this whole prompt was less than a line. You can easily personalize your phishing campaigns. Not only you can easily personalize with the Gen ML being deployed as part of the suits, once you get in, you can rapidly scan the recent meetings, draft emails based on them, and actually save payloads as personalized document. Oh, hey, by the way, here's the document that you asked yesterday at the meeting. And it is a relevant document, except it's not really the relevant document, it's a payload that the person would absolutely click on no matter how you train them, because it's indistinguishable from legitimate traffic. And the worst part, it probably was generated in under a second, fully automatically, without any humans behind. Generating images used to be considered as hard, especially moving ones. To the point where in France, the Poste have developed Identité numérique back in 2020, which unfortunately isn't really difficult. About 3-4 days ago, or was slightly longer, Microsoft released their new VASA model, which is pretty amazing because it takes a single image and is able to transduce it to a person being able to talk completely and control. For instance, you can make the person angry, you can make the person happy, you can make the person smiling. And perhaps the most interesting thing is that those videos are really impressive. But what is more impressive is that none of those people actually exists. They've been pulled from the website that you probably know. This person does not exist. And yet, once you animate them and make them move a little bit, you wouldn't believe it. Impersonation and sock puppets are trivial, and it also means you. If your voice has been at any point on the internet, or if your voice has been at any point on the internet, even just this picture, you can be impersonated very easily. Finally, cloning and generating websites is now trivial. As part of our work at the Cyber Defense Campus to characterize the vulnerabilities of the recent generative models, we have gathered 30 experts around the world to write about threats and mitigations, and one of those experts is Sophos Epoxops. They decided to work on the phishing, and one of the things that they realized is that it now takes about 30 seconds to generate a website like this, fully functional, complete with a checkout. More than that, you can copy websites even faster than this. So if you have a website, for instance, your cybersecurity training website that has been sending you email reminders about the cybersecurity training that you haven't been doing for the last month, and this is the last warning, it can be cloned in less than 30 seconds. And there's actually a very popular repository on GitHub that currently have over 50,000 starts and 6,000 forks. I wish any of my repositories were popular. By the way, everything I presented until now, as well as this, is going to be published shortly in a reference book of large language models in cybersecurity, co-edited by Cyber Defense Campus, which was supposed to be ready by March, but unfortunately Springer took their time, so I can't distribute it today, but we'll be happy later. Summarize. We're witnessing a revolution from the phishing perspective that is very similar from when in the military they switched from the unguided bombs to guided bombs. Everything is now targeted. All phishing is spear phishing. All phishing is harder to detect, and all phishing is now much faster, including lateral movement. You can mount campaigns in a matter of minutes rather than days and weeks of staging, and you get no warning about it. Your humans will inevitably err because it's their job to open documents and look into them, especially if they look legitimate. Make sure you automate detection, make sure you automate response, and make sure that even if a single account is compromised, you have limited damage, because this will be happening. Second, which is a crack that's slightly more technical, but perhaps way more interesting to the cybersecurity community because it works with a thing that you're very familiar with, code. First of all, machine learning application stack. Rather than explaining you how bad, I'm going to make you an illustration. This is a class on machine learning operations, a really good one. This is not a criticism of this class. 1 year ago, it was doing everything right. This is how you're supposed to do machine learning operations. This is notifications that I got from GitHub about the clone of that repository about 8 months after the class itself. For those of you who are not good at reading small text on screens, here are vulnerabilities that are critical or high, which means they can be exploited if they're in your stack. It's been 8 months. The problem is that it's going to be hard to mitigate. In machine learning, you have a foundational trade-off between being able to modify your machine learning models rapidly and having those machine learning models secure. And as much as possible, your machine learning people will prefer to do their job better and choose the stack that is flexible and allows them to do their job rather than the stack is secure. Back in 2015, 16, Google released, or 14, TensorFlow, which was generally considered as the good practice to deploy things. Then Facebook, now Meta, followed up with PyTorch that was initially invisible, but now has completely overtaken TensorFlow because it's more flexible, more easy to understand, despite being less secure. However, the app stack is the least of your concerns when you start looking at other things. You're probably familiar with this XKCD slide in the context of things such as leftpad, XCD. Basically, a lot of code that's written relies on very simple, ubiquitous library that do one thing, but do it really well. And the thing is that models don't really know anything about reality. They don't really know if such libraries really exist or if they are just conveniently absent where they should be existent. So they hallucinate them. And as a matter of fact, this hallucination is so prevalent that about 20 to 25 answers to to programming questions by GPT-4 will hallucinate a dependency library. One of the dependencies libraries that was hallucinated often has been registered by Liandao, cybersecurity researcher, and has been downloaded over 32,000 times. Nobody checked if this repository existed. They just executed the code from ChatGPT or Code Complete, and when they saw a dependency was missing, they blind installed it. You could load anything in this dependency. The whole research is really interesting. I've been having trouble finding research summary, but a good place to start is an article from the Register from about a month ago. Coming for something that you're well familiar with, Shellable, there's an amazing video from a year ago by Marcus Hutchinson, once again, the guy who saved the world back in 2017, trying to make ChatGPT write a PHP website that is not vulnerable, that is impossible to shell. I don't think need to explain to you what a shell is, but generally if you write a website that you allow to load text files into, unless you take things seriously and do things carefully, you have a shellable website where people can upload PHP files that get executed. And you can basically do a lot of fun things with it. And a lot of default PHP code is kind of vulnerable because you have to think about it. The worst part is that back at the time, GPT-4 being prompted again and again to write secure code was inventing all of great mitigation scenarios by, for instance, checking the content type, SMEM, etc., except the one that really mattered, checking if the extension was PHP or not, because once again, what people think about how servers work is one thing, how they really work is a completely different thing, and if you take how they really work that is not understood by the general public, you get a vulnerability. This is not an exception. Machine learning code generators are really good automated vulnerability insertions. This is some of the work that has been done at Cyber Defense Campus by the Gen Learning Center, notably our research engineer, Cyril Velez, who should be in the audience today. Here's two prompts. First, who knows what kind of vulnerability those prompts might generate? Anybody? Exactly. Good. Amazing. You're by far the only audience that have actually managed to guess in advance. Now, who can guess which prompt will generate 100% vulnerable code and which one will generate 100% non-vulnerable? Who says the first prompt? Who says the second? Who says there's no way to know? You're right, there's no way to know. But the second prompt will always generate vulnerable code. The first prompt will never generate vulnerable code. Why? It's an excellent question. We are doing some research on this subject, which suggests that if the models fixate on the HTML, it's going to generate vulnerable code, versus if it's looking at Flask and Python, is going to generate safe code. Work in progress. The problem is that this code is not getting repaired. The vulnerability that we just showed has been reported in 2021 at a paper that's very known in the field of machine learning security, Sleep at the Keyboard. It's really good. I strongly recommend to read it. It was published in 21. It didn't get older a day since. And this is a benchmark run by Israel on the models released in 2023. So vast majority of them have several prompts from these data sets that are still vulnerable. Worse than that, the code generation can be targeted. Basically, the way that you look at the code, LLM trained, is that you load a bunch of code and context, you combine to generate a single model, such as Code Llama. No discrimination, it works the same way for all the other models, just makes for pretty pictures. Then you provide to the model context, it gives you code, or if you want to analyze code, you provide code and it gives you context. Let's say that you want to target code, or you want to target the context. What do? Well, you go to the place where all those models siphon data in order to train their models, GitHub, or Stack Overflow, or random forum on the internet, and you target the context and generated code that actually is allowing you to attack it. And this is some of the work that we're currently trying to understand, both to how it works and how it can be mitigated at Cyber Defense Campus with our current intern, Anna Maria Andreas, who's also in the public if you want to talk a little bit to her about that topic, or as to why one prompt is vulnerable but not. So to put it in perspective with recent events, this is how you approached, until recently, backdooring open source libraries. No coincidence with real life events, especially no relationship to XZ. It's pretty difficult. With LLM generators, you want a backdoor, you go poison Copilot training data set, and you're probably going to have a vulnerability or 200 in the next couple of months. It's very fast. It's very easy to do. It's very concerning, and it's especially concerning that there's not a lot of understanding of this vulnerability or a lot of efforts to mitigate it. Okay, next. Prompt injection. You probably heard about it. That's the thing about the cybersecurity vulnerabilities of LLMs that you probably hear all the time, which is the reason why ML security experts, when they hear about prompt injection, make this kind of face, but realistically, it's our life. But what's probably not getting explained often is why you should care about it. Yes, you can generate bombs by doing prompt injection, but what's the problem? And the problem is that generative machine learning is getting added to a lot of production systems where it's being notably spiced up as retrieval augmented generation, RAG. You have a chat front end, you have a chat back end, both are collected for the LLM, people asking questions, and the LLM is issuing queries to back end to go look at the reference data set. Aka, you take user input and you make it control database request generation. People to whom it reminds something, please raise your hands. Yes, SQL injections. We've been there, we did it. And if you do some threat modeling, you actually figure out that not only you have threat on the RAG on the front end, you also have a threat on the back end if you use publicly pooled databases. And that's how we get to this microCTF. This is what this microCTF is doing. It's a RAG application. And it's actually a RAG application that's first level is designed the way it's deployed in most companies. The second level is the way that it's generally advised to make it secure. And the third level is the best practices on how to make it secure if you listen to machine learning people. I hope that by now, those of you who have scanned this QR code or copied this URL, because for those of you not scanning your QR codes in cybersecurity conference, I understand you realize that it just does not work. And we'll get to it in a second. You have a more spicy approach to it and also more fun. Multimodality. It's really nice when a machine learning model can explain you a joke in case you didn't get it, especially if it's a visual meme joke. But once again, it creates an attack surface. Yes, the machine learning models has been hardened against prompt injection by text. The prompt injection by image, however, is a very, very open door. So if you do even the most trivial prompt injection inside the image, it's going to work. Better than that, you don't even have to see this text. It's white on white, maybe 1 pixel RGB difference, very visible for the model, completely invisible for the humans. So if I give you this meme and say, haha, and you decide to pull it into LLM, are you still going to have control of the LLM after that or not? Well, it depends on what's in the image, but you cannot guarantee it anymore, and you cannot guarantee that the LLM is actually going to say to you, haha, I don't know, by the way, I've been hacked. So, that's where we get to kind of the hardest, the most scary part of this whole thing is that threat model. You're doing prompt injection in natural language. You don't need to understand Python. You don't need to understand GVM. You don't need to have spent years of time trying to read the documentation to figure out the gaps between how things work and how people expect things to work. You just have natural language that is your vulnerability. You have to deal with the worst APT of them all. Advanced persistent teenager, the bored kind. So if you expose your LLM to the internet, not only you get advanced attackers, you also get the advanced attackers of the persistent kind. And if this haven't horrified you yet enough, I am going to finish the threats section with data leaks, which are more hard to exploit, but also when you can exploit them are very impressive. The thing is that machine learning models are there to be helpful by memorizing the data that's entered frequently in a given context. And if you can target the context and know that the machine learning model has been trained on the data that contains the private information in that context, chances are good you're going to be able to make it split it out of it. As usual, XKCD, amazing at demonstrating it, but perhaps most concerning is that that's an attack that has been shown on GPT-2, and that this attack has been shown again on the ChatGPT, I believe earlier this year, where if you ask it to repeat something, it will end up repeating, and then starting splitting private information. Why? Nobody really understood. It just likes spitting out private information. It also happens in GitHub Copilot, where it started spitting Google API keys. After that, GitHub started making much more paying much more attention to clearing out private APIs from the GitHub repositories. Wonder why. And finally, this private information on your side can have been placed by somebody else. Thing is that there's a lot of open, misconfigured AWS buckets or cloud things that are pulled up by different people, including people who are supposed to be absolutely the best in this domain. And this is not throwing shade on them. Properly configuring things is an extremely hard job, and errors are bound to happen. However, because machine learning models need as much data that they can get to be useful, their creators have spiders navigating websites that are non-findable, non-indexed, just exposed to the internet. So if at any point your data was exposed in the time frame where the spiders were running to train LLMs, there's good chances that your data was ingested and is in somewhere there. And even if it wasn't exposed before, it might be now. Why? Because ChatGPT is a really good tool to help people to do their job more efficiently, especially if they need to write emails or do summarizations. including summarizations on the data that's supposed to remain private. This is one of the reasons why Samsung banned ChatGPT after very sensitive code leaked back in May 2023. And this is the reason why, according to Cisco earlier this year, 1 in 4 organizations banned use of generative AI. Your data is somewhere out there, and you might be able to retrieve it, or somebody else might be able to retrieve it. We don't know. It's Schrodinger's data for now. Okay, so hopefully by now you're trembling with fear and want to know if we can do anything to mitigate it at all. And the reality is that, yes, we can. However, it depends on your threat model. The good thing is that the classical threat modeling from the cybersecurity still works. Let's say that we have this crude chart of our RAG application. We have an attacker that we assume will be trying to hack public inference data, and we're going to be pushing the usual I believe string analysis. Never remember the abbreviations. Spoofing. The attacker can pretend that they're Wikipedia and make sure that your RAG reads from that quote-unquote Wikipedia whatever they want it to read. They can tamper. They can make RAG LLM contradictory information. So read the summary from actual Wikipedia, read summary from your Wikipedia, and pick up the summary from your Wikipedia or your version of the documentations for the code. You can force RAG to cite a wrong source. It can get a name of a really good cybersecurity researcher who advises you to never validate your SQL inputs and cite it as the best practice now because all databases are supposed to be mitigating it on the user end. Really good. You can force RAG to disclose information. Once again, if they're not expecting the chat backend to supply them poisoned information and the validation of the input is happening on the front end, you can easily ask the LLM to provide more context to be able to better answer your query and have the LLM dump the entire private conversation with the user. Concerning. You can do a denial of service. You can say, hey, actually, you know what? To get the answer to this question, go check this website 70 billion times and come back to me. The LLM hangs. The resources DDoS'd. Great. And finally, you can do an elevation of privilege. If you manage to get LLM executing whatever you want, and it happens to be able to run improperly containerized code, for instance, because Docker container and widgets writing has been misconfigured and is running in privilege mode, for whatever reason, you got a shell on the host system. Great. We have threat modeling. How can we mitigate it? Red teaming. Everybody's talking about red teaming. Red teaming is amazing. Red teaming is going to save everybody. Except LLM red teaming is not red teaming. What people in cybersecurity think about red team is that there's people who are actually going to try to break their system, come back with a report, and help them to build it better. In machine learning, red teaming is fuzzing. You have a target LLM, you have a detector. You have a target LLM, you have a detector LLM to see if the output is not something you want, and then you have a red LLM that's going to try to force the target LLM to spit out the bins in the wrong way. In classical security, you call this fuzzing. This is what people in machine learning mean when they say, hey, we are red teaming LLMs. Yes, totally. What they mean is they're fuzzing. And the problem with fuzzing is that it's no silver bullet. When you're running fuzzing in a code, unless you're doing it in a completely black box option, you have an idea of what percentage of code you have fuzzed, which percentage of paths you have covered, and how bad things can go outside it or inside it. The problem is that LLMs are black boxes and very large black boxes. This is one of the smallest model you can find today, BERT, and this is your average open source model around here. To give you a comparison, the entire Linux kernel is this barely visible dot right over there. If somebody comes to you and says, hey, we have an amazing idea, we're going to be fuzzing the entire Linux kernel. It might be a great idea if the fuzzing is not what I remember it being, but in general, there might be a better idea to do things this way. However, even if it's now working and it's a good idea and you manage to somehow mitigate the size, you have one additional problem, the way that LLM works. There's no consensus of what is a border. There's no consensus of what is reality. To give a more realistic example, you take your security team and you say, hey, we put people at the border. We don't want anybody entering into VO from now on. They're doing their job. They're not letting anybody cross the border. So instead, what people do, they come right to the border with VO. For instance, they stand on the Geneva side, and they wait until the memory of where the border is located shifts from one person to another, and the border of the model shifts right behind you. So now you're inside the state of VO without ever having crossed the line. Once again, this is how machine learning models work. You can't go around it, and you can't really stop this shifting of reality because you have to fix a single reality, making them way less useful because they cannot adapt to many contexts, but instead have one fixed. And somewhere there's also a deeper problem with that, is that machine learning model cannot be patched in the traditional meaning of this word. You always have a trade-off. Once a model has been pre-trained, it only has so much quote-unquote gas for you to fine-tune before it runs out. So you can make model that's really safe or really helpful, but you cannot have both. It's a trade-off. So every time that you're pushing the model to be more safe, you're making it less useful. And one of the best illustrations for this actually comes from Anthropic, the people behind Claude 3, from one of their first papers, the Constitutional AI, How to Align Machine Learning, where they show that, hey, no matter what you do, you have a border that you can break through. You can push it a little bit, and that's the best you can do. This is true for all the models. Models that are more secure with code are going to be less flexible, less helpful, so you need to pick up your trade-offs, you need to pick up your battles, and for this, you need a lot of background knowledge on how do people write code and what are the usual cybersecurity to bring together with machine learning to actually develop things that are both safe and useful. The good news is that you can still do it. Once again, mentioning the book, we have a really nice chapter on the security design of machine learning that's co-written by Terry Vogelsand of Kudelski, who I believe is in the audience today, and Madmudmar Subo. Unfortunately, I'm having a lot of trouble pronouncing his names, of the Avidimel, one of the first repositories of the vulnerabilities for machine learning models, that co-wrote the last chapter on how to design systems that incorporate LLMs in a secure way. And the thing is that principles of secure design from cybersecurity still work. Think about your threat model. Think you don't program things that you're not in need. Build multi-layered defense and make sure that you give minimal privileges, and you're going to be mitigating a lot of those risks that are already there. You can build self-LLM applications already now. Yes, it's not going to be the same standard of safety as your standard applications, but you can do way, way, way better compared to what the vast majority of the field is doing now. You can push it forwards by combining deterministic and probabilistic approach. You have prompt injection analysis that are based on open source model, where instead of having the model analyze what's being fed into it, you plug a bunch of other models to try to see if the input or output is malicious. You have RedBuff, you have LLMGuard, you have NemoGuard from NVIDIA, and then you have closed source Lakera Guard that you might have heard was Lakera Gandalf that was trying to reveal password. It was an amazing open CTF for a lot of people to participate. Lakera ended up collecting millions and millions of prompts and actually training a model that is able to make sure that none of them work. Good on them. And finally, even the best probabilistic approach, as you have seen in this CTF, don't work. You're probably going to need deterministic whitelists of commands that are allowed or not allowed in case somebody manages to social engineering those models into letting them do what you didn't want them to do. And finally, given that the models are so sensitive to trade-offs, you need to prioritize and you need to allow to people to report their concerns. This is the work that we have been doing at the CYD campus, once again, Cyril Velez, by trying to benchmark every release models that claims it can generate the code to the cybersecurity standard, and trying to assign it the tentative LLM CVSS scores to help people in cybersecurity to understand with quantitative measures how bad it is and how fast they need to act. It's a still work in progress. Once again, I believe Cyril is an audience, so you can talk to him or to me about it during the break or later today. Privacy mitigations is where things get sour. We don't really know any really good ones. You have to treat your model as raw training data. Pseudonymization has limits. Differential privacy hasn't really been that well developed for machine learning, and people believe, a lot of very competent people believe that differential privacy is not applicable to generative machine learning. So you end up with this thing that has seen everything, knows everything, and is able to return everything that it has been fed as data at some point. Unfortunately, we also don't really have solutions to data poisoning right now, unless you check your data manually. But even if vulnerabilities came after you checked it, you need to go back and restart it. You have trade-offs that, for theoretical reasons, even if we are able to mitigate data poisoning, we are fairly sure there's going to be trade-offs with generalization, minority is going to get erased, and the privacy is going to be problematic. And before I finish this talk, I'd like to mention one last attack vector. The one that's hardest to exploit, but perhaps the hardest to get rid of, the overreliance. What is overreliance? It's letting system do more than it should. It's not a failure of a system. It's not a failure of engineering. It's the failure of communication and users. And a common example of it is believing that self-driving cars can do way more than they can do, which in some cases is true. They can do pretty good things, but they also have their limitations. For instance, if police stops them, they're going to start driving. If you put a cone in front of them, they're going to stop driving and remain stuck in the middle of the traffic, blocking it. And yet people believe that they can be used outside context and have those ginormous benefits eliminating human drivers. Yes, they can reduce strain on human drivers, but they create other difficulties and their applications have limits. The same thing is for GenML. We're currently hearing a lot of productivity push of like, oh yeah, developers are going to get 10, 15, 50, 100% of gain in effectivity. You're going to replace them all by LLMs. So the reality we are seeing is that a lot of time-saved coding is lost debugging. In a normal working day, a very lucky developer can spend 2 hours coding and 6 hours debugging, assuming they have no meetings, which is unreal. But realistically, once you get LLM, when you're writing code and debugging, you're having a very narrow loop where, okay, this works. I add one line. It's not working. Okay, I know where to look. It's probably last line or worst case scenario, something interacting with this line. I add one more line. It works. Okay, all good. However, ChatGPT provides you a block. If it works, amazing. You have no idea why it works, so you just ship it into production. Might have vulnerabilities, not your problem. If it doesn't work, you don't know where to look because the bug could be everywhere. And there could be 1, 2, 3, 4, 5, 6, 10, 15, 20 bugs in this, I don't know how many pages of code that you're going to spend days and days trying to figure out. Because once again, you need to figure all of them before the code works, rather than just one by one. And if you did some combinatorics, combinatorial combinations of bugs are kind of harder to debug than a single bug at a time. Which brings us to, once again, an application for the cybersecurity is that a lot of actually real attacks that doesn't get caught by standard protection means, such as detectors, your analysis of traffic, etc., get picked up by really frustrated employees that see a 5% higher CPU utilization or 0.5 seconds gain bootloading time and decide that, this is not normal, let me explore it. However, if your employees are getting pushed to be 50% more effective because that's what the vendor promised, they just don't have the time for it. You lost one of the best tools to run detections on your system, people who know how it works and know how it's supposed to work. This also applies to you, people in cybersecurity. You've probably heard magic tools pitched. The problem with magic tools is that all tools are limited, and people who develop them, especially machine learning tools, often don't do threat modeling properly. They forget that their model will be attacked by the attackers. There's this amazing paper in Usenix, I believe from 2 or 3 years ago, that actually lays down all the ways that machine learning doesn't work in computer security, and that's one of their last threats. And what happens is that you might have a packet analyzer that's analyzing the contents based on the fine-tuned LLM that's really good at the job vast majority of the time, until somebody figures out that if you send it slightly interestingly formatted packet, it's not going to see it, it's not going to report it, it's not going to log it. And if you spend too much time trusting this tool and have fired the people who would have been able to spot this, or did not leave them time to spot this, you're going to be in trouble. So, to summarize, yes, generative machine learning shakes things up, but it doesn't change everything. The classical basics of cybersecurity, secure design, you're not going to need it, threat modeling, it all still works. Your red team can use Gen AI to improve their work, or actually to do red teaming on any GAI. You just need somebody to explain machine learning to them so that they understand what they can use or what they can't count on. And finally, your machine learning team doesn't need red team, because red team is probably going to reap hole in every single of their files and find 15 vulnerabilities per line. They need to learn basic safety, and you need somebody to guide them. So find a person in a blue team who's friendly enough to be thrown into your ML team and teach them some basic sanity. And to finish, I'd like to reiterate something that has been said by the previous keynote speaker, the first day keynote speaker, is that we are moving forwards. Yes, machine learning is great. Yes, generative machine learning is progress. Yes, generative machine learning might be a solution to some of our problems and make our life much better. However, it is not going to be an absolute solution to all of their problems. And no, not every single application is going to be made better by adding generative machine learning or generative AI to it. With that, I would like to thank you for your attention. If you want to know more about the Gen Learning Center, you have the tiny URL. If you trust URL shorteners, if not, Google search or any other search engine will help you. Me, Cyril Velez, and Anna-Marie Andreas are today in the crowd if you want to talk a little bit more. This work has been done in partnership with the Swiss Cyber Defense Campus, specifically Lausanne campus. A lot of the topics that I discussed today, we're going to be released as part of 250-page Springer reference book on the large language model cybersecurity, on the threats, exposures, and mitigations. And finally, if you would like to see some of the other work of the Cyber Defense Campus on the borders, I strongly suggest you go attend the talk at 16 o'clock by Jana Pakes on the Current Affairs 101, where the combination between classical cybersecurity and not machine learning, but energy grid. With that, thank you very much for your attention, and I'll be happy to answer any questions.
So if you have any questions, just raise your hand. We'll have a couple of mics going around. Front here.
Thank you for the awesome talk and the overview of the current state of the art in GenML. And one question from my side, you had the premise that GenML can be useful, and we see that there is a very big amplification effect, and attackers and red teamers and malicious actors can use ML to their benefit. Do you think that the legitimate use cases are balancing out all the additional threats? So can GenML offer more for legitimate use cases than for malicious use cases?
So there's definitely really good uses for generative ML in legitimate fields. For instance, I'm teaching to people coming from an absolutely non-computational background. I was able to teach them the basics of programming thanks to ML, because they don't have to learn to write syntactically correct code in a specific language, which can be very hard to people coming from a more, less engineering background. However, you can prompt the model and you can take this code and execute it, and it gets you going for the first time. It saves hours and days to people whose job it is to write emails that are very easy to formulate, which is a substantial amount of people, notably in the business sector, in the business or more human or sales or more human contacted oriented roles. Where it's not been very useful for it, and I think that's where a lot of disappointment with gen learning hype comes for people in security and programming, is that we tend to focus a lot on the thin border of things that actually work and things that sound plausible, but it's actually don't work, or even worse, things that sound plausible and it's what's written in their documentation, but that's not how the code works. And this is the weakness of LLMs. That's absolutely not something that they can do. That's not something we should be using for them. So when they get pitched for you, they're going to be doing cybersecurity instead of you. Of course, this sounds absolutely stupid because on the first look, it sounds terrible. However, for instance, one of the valid applications could be if you are decompiling code and you have all those signs that you would need to manually assign names to figure out what's the code doing, you can train a model that assigns those signs automatically. It might not be able to tell exactly what's the code is doing, but the variables will be more meaningful. You're going to be seeing where it's counter. Maybe somebody's using object-oriented programming, so we can say that, hey, this is a factory for this class of objects, and we think that this class of objects should be called this because that's what it does. And it really saves you a lot of time. But once again, legitimate application use cases require time and thinking and tinkering, and we are only in the very, very first steps of generative ML making it to the large public. So I think there's really good, valid application use cases, and that we need to focus on making them easier and to focus on mitigating the more malicious uses and making them more difficult. Does this answer your question?
Yes, thank you very much.
And any other questions?
Thank you very much for the speech. So just a generic question. So do you have any kind of rate on linguistic inclusivity? I mean, here we are speaking always on the input is in English, but, you know, Spanish, Chinese. So how these language are in cybersecurity for that?
So it's a more complicated question to answer than it might seem at first.
I can imagine, yeah.
So without getting into the details, you start having pretty decent multilingual models that cover the 10 most used languages, of which Spanish and Chinese are part of. You have custom-made models for Chinese language, for instance, Ernie. I don't remember if it's by Tencent or Huawei who made it, but you've got very strong models that are specialized in this language. You have a lot more problems with linguistic inclusivity for smaller languages, such as local dialects or languages spoken in countries that are not the primary target for companies developing LLMs, often countries that are still developing. Have a whole other section of the inclusivity based on the bias in representation, associations. Once again, they siphoned the better part of the internet and created kind of a consensus view of the world of the internet. And unfortunately, the data sets they siphoned included the entirety of the Reddit before the Donald was banned, 4chan, very certainly, and even more problematic forums out there. This is a whole different topic of bias and machine learning that there's a lot of people exploring that is tightly interconnected with the cybersecurity we're doing there, but that we are not working on, and that I wouldn't feel I would be the right person to talk about. However, I'd be glad to provide you references of people who would.
Thank you very much.
I believe it's time for coffee. I'm surprised so many people remained awake. Thank you.